So if you've ever found yourself wrestling with a massive, tangled prompt, or just been completely frustrated by an AI agent going off the rails, you already know the limits of a single agent system. Today, we're going to explore a much better way to build, creating AI that's robust and reliable by thinking not in terms of one super agent, but a whole team of them.
You know this old saying? It absolutely nails the problem with so many large language model applications today. We keep trying to build one single genius agent that can do everything. But that jack-of-all-trades approach, well, it's fundamentally flawed.
I mean, think about it. It's just like in traditional software development, right? Trying to stuff all your logic into one giant application is just a recipe for disaster. For an AI agent, the more complicated its instructions get, the more it just struggles. It starts to forget rules, the error rates shoot up, and you get those infamous hallucinations. And the worst part? When it breaks, you're stuck tearing apart this huge tangled mess of a prompt just to find the bug.
So there's a name for this, and it's the monolithic AI problem. Let's really dig into why the single agent approach fails. Because, understanding the problem is the only way we're going to get to the solution.
Okay, so if a single monolithic agent is the problem, the solution becomes kind of obvious, doesn't it? The future isn't about building one smarter agent, it's about building a smarter team of agents. Let's really explore what it means to start thinking in agent teams.
And here's the beautiful insight. The software world has already solved this exact problem. We moved away from those giant monolithic apps and broke them down into specialized microservices. And we're seeing the exact same shift happening in AI right now, moving from a monolithic agent to what we call multi-agent systems.
So what exactly is a multi-agent system? Well, you can think of it as basically an AI microservices architecture. Instead of one agent trying to do everything, you have a whole team of specialists. You might have a parser, and a critic, and a summarizer. And this approach makes your entire system modular, way easier to test, and just dramatically more reliable.
Okay, so the theory makes a ton of sense, but how do you actually structure these agent teams in the real world? Let's get practical and start with two of the most fundamental patterns out there, linear and branching.
First up, we've got this sequential pipeline. And honestly, the best way to think about this is a factory assembly line. Agent A does its one job, then it passes its work directly to Agent B, who then passes it to Agent C. It's just a straight line. It's predictable, and because it's so predictable, it's incredibly easy to figure out what's going on if something goes wrong.
Here's a perfect example. Let's say you're processing a document. First, a parser agent grabs a messy PDF, and its only job is to turn it into clean text. That's it. Then, it hands that text to an extractor agent, whose sole purpose is to find and pull out structured data, like names and dates. Finally, that neat structured data goes to the summarizer agent to create the final output. See? Each agent is a specialist.
And the best part is how incredibly simple this is to orchestrate. Instead of writing a bunch of complicated logic to pass data between agents, a lot of modern frameworks let you just define your specialists, the parser, the extractor, the summarizer, and then list them in order. The framework just handles the entire pipeline for you. It's awesome.
But what if the path isn't a straight line? That's where the coordinator pattern comes in. Think of this agent like a smart concierge at a hotel, or maybe a dispatcher. Its one and only job is to look at an incoming request and route it to the right specialist on the team. This is absolutely perfect for something like a customer support bot. A user might have a question about billing, or maybe they have a technical problem. The coordinator agent doesn't even try to answer those questions itself. It simply understands the user's intent and goes, that's a billing question. I'll send you right over to the billing specialist.
Now here's the really clever part. This routing isn't controlled by a bunch of complex if-else code. Nope. Instead, you just give the coordinator agent a simple instruction in plain English defining which specialist handles which type of request. The LLM itself then interprets what the user needs and makes the routing decision. It's brilliant.
So far, we've seen agents working in a nice straight line and agents that can branch the workflow. But what if you need to guarantee quality? For that, we need to introduce loops. So let's look at iterative patterns that are designed to refine and perfect an output.
This one is called the generator and critic pattern, and I like to call it the editor's desk. It's a fantastic model for quality control. You have one agent, the generator, and its job is to create something, maybe a piece of code or an email, anything. And then you have a second agent, the critic, whose only job is to check that work against a very strict set of rules.
So here's how that loop works. The generator writes a draft, let's say a SQL query. The critic then checks it,
Is the syntax valid? If not, it fails the draft and sends feedback to the generator, which then has to try again. But if the draft is valid, the critic gives it a pass, the loop exits, and the final output is approved. It's basically a quality gate.
And this whole process is implemented so elegantly. The entire quality control loop can be managed by a single agent wrapper. You just have to define the exit condition. For example, the loop only stops when the critic agent's output is literally the word pass. This creates a simple but an incredibly powerful quality gate for your system.
Okay, now let's look at a similar but very distinct pattern: iterative refinement. The best analogy here is a sculptor. This isn't about a simple pass or fail. This is about taking a rough draft and progressively making it better and better and better with each cycle.
And this slide really clarifies the difference perfectly. The generator and critic pattern is all about correctness. Is the code valid? Yes or no? Iterative refinement, on the other hand, is focused on qualitative improvement. The code might already be valid, but can we make it faster? Can we make this paragraph more persuasive? It's all about polishing and optimizing, not just passing a simple test.
All right, so we have our building blocks, we've got linear pipelines, we have branching coordinators, and we have quality control loops. Now for the most important part. Let's see how all these pieces get assembled into sophisticated, real-world applications.
The key takeaway here is that you'll almost never use just one of these patterns by itself. Production-grade systems are composites. They mix and match them like Lego bricks. For instance, think about that support bot again. A request comes in. A coordinator agent first routes it to a technical issue team. That team might then trigger a generator and critic loop to make sure the support response they draft is technically accurate before it ever gets sent to the user. That's how you build a truly robust system. So before you start building, here are 3 essential pro tips. First, get your state management right. An agent's output is the next agent's input, so you have to name things clearly, like extracted text or final summary, so the system stays predictable. Second, write really precise agent descriptions. A coordinator agent literally uses these descriptions to decide how to route tasks, so they are your most important form of documentation. And finally, start simple. Master the sequential pipeline before you even think about introducing loops and branches. It really is the best way to learn. And that's your starting toolkit. We've just walked through some of the most foundational patterns, linear, branching, and iterative, that form the core of good multi-agent design. By shifting from that old, single, monolithic approach to these modular teams, you can build AI systems that are just so much more reliable and easier to maintain.
And that leaves us with one final thought to take away. We're learning that the most effective way to build artificial intelligence is to create these focused teams of specialists who collaborate. So, what does that tell us about the best way to design our own human teams and organizations? Something to think about. Thanks for tuning in.